45 years ago, Michael Brown and Joseph Goldstein, two physician trainees at the National Institutes of Health, were fascinated by an unusual clinical case. Their patient was a 6-year-old girl who was admitted because she was having heart attacks. The arteries that supply blood to her heart were being blocked by deposits of cholesterol. What is usually a problem seen in 60-year-old men was so debilitating for the 6-year-old girl that she could barely walk across the room without having crushing chest pain. She had 10 times the normal number of cholesterol-carrying proteins in her blood. These proteins, medically abbreviated as LDL, are what we colloquially know of as bad cholesterol and tends to form plaques in our blood vessels. Frustrated by how little they could do to treat the patient, Goldstein and Brown wondered, what controls the levels of LDL in our blood? If they could understand the factors behind cholesterol metabolism, maybe they could help their patient. They went back to basic biology and discovered that cells have receptors that can bind to LDL particles and remove bad cholesterol from circulation. Their groundbreaking work would forever change the face of medicine and win them the 1985 Nobel Prize in Physiology. Ladies and gentlemen, please welcome my guests at this time, the Distinguished Chair in Cholesterol Research and the Chair in Medicine at the University of Texas Southwestern Medical Center, the 1985 Nobel Laureate, Dr. Michael Brown. Dr. Brown, welcome to the show.
Thank you.
So, you and Dr. Goldstein have run a lab together for more than 4 decades. You must have come across clash of ideas, conflicting thoughts, and in a sense it means giving up your own individual scientific identity. And I think that's where historically most partnerships have come apart. So as the longest scientific partnership in the history of biomedical research, what has kept you all going?
Thank you. That's a very good question. And there are lots of things that go into this kind of relationship. I think the most important one is mutual respect. I respect Joe Goldstein and his opinions about everything. Fortunately, he feels the same way about me. That doesn't mean that we always agree. In fact, we have lots and lots of arguments. But the way I phrase it is this, that a partnership like this requires that one of the partners, and only one of the partners, be a saint. Now, just think about the possibilities, okay? If neither partner is a saint, they're going to be fighting each other all the time. If both partners are saints, they won't criticize each other and you won't learn anything. So if you can't be no saint, as a mathematician, you must know that if you can't have no saints and you can't have two saints, the only other possibility is one saint, okay? And I ain't a saint. So we have to have respect for each other. That's very important. And I think you have to have the feeling that the other person brings to the partnership something that you don't have. We wanted to solve the problem of these children, as you mentioned. And we were going to collaborate, to work together to solve it, but we never had the notion that we would be so intimately working together that we would form a joint laboratory. I mean, the vision was that we'd each have our own laboratory, but we would sort of collaborate on one project. But as the project began to advance, and we also, both of us had separate other projects going on in the beginning, but as this joint project began to advance, we gradually gave up the other projects and both of us focused on this one partnership. And then we started to think, well, what is it really going to mean if we work together like this, okay? I mean, how am I going to get promoted? Or how is he, in academia in general, when you get promoted to being a professor, they want to judge you and what your contribution is. But if everything is jointly published, then how do they know which one of us was responsible? The other issue is that the only way that this can work is if we don't claim separate credit for ideas. So if I say something that's brilliant on a Wednesday, it's because he said something on Tuesday that planted the seed. And therefore, I can't take separate credit for anything. And so you will never, in the 44 years that we've been working together, you will never see anything that says, this was Joe Goldstein's idea, this was Mike Brown's idea. So we basically submerged our egos into this partnership. And you have to understand that both of us were super achievers, okay? We were both always at the top of our class all the way through every education, and we had a lot of honors before as individuals. But we decided to submerge that, and it took a while. For example, you start to get invitations to give lectures, and we decided that we would rotate those. So if a certain society happened to call me up, but I had given the last lecture, I would tell them, no, invite Dr. Goldstein, and vice versa. We rotated authorships. The senior author on a scientific paper is the last author. So if you look back at the first many years of our collaboration, you'll see that every paper rotates the last author. It has nothing to do with whose idea it was. And, you know, I don't know of any other partnership that's done it quite that way, but, and there have been many successful scientific partnerships, but they're usually transient, and they involve two people coming together to do one specific thing, but then they separate. It happens that my medical school fostered this kind of thing. So when each of us was promoted, like from assistant professor to associate professor, we were both promoted at the same time, and then professor, you know, up to professor. And then, fortunately, the rest of the world recognized this, so that when we were elected to the National Academy, we were elected in the same year. It would have been very destabilizing if one of us had gotten some recognition that the other one hadn't. That might have been very destabilizing. But the faculty and the leaders of our school made it absolutely clear that we were to be evaluated as partners rather than as individuals, and so it worked.
I find that incredibly fascinating, and I wish that more schools and more environments allowed such collaborations to foster in a healthy way.
Yeah.
Now, going back to the early phase of your career, you continued seeing patients as well as running a lab.
Yeah.
So what was the importance of seeing patients while being a researcher, and vice versa?
I loved seeing patients. You know, I prided myself in being a good physician, and you know, that was my original motivation for going to medical school in the first place. So I enjoyed making rounds. I enjoyed teaching the residents and medical students. After we received the Nobel Prize, it became a little difficult. For one thing, there are many distractions. You know, lots of invitations to do things after the Nobel Prize. And secondly, I realized that I wasn't quite as sharp a clinician as I had been. I had the last time I was attending physician on the medicine wards, I had this terrific resident, a really very bright, gentle person. And so I would go into the patient's room with the students and the residents and the interns, and I would question the patient, examine the patient, and then as I was walking out, I would think about the thing that I'd forgotten to ask, you know, because I'd losing my reflexes, and so I had too much pride in my, and the resident would actually kind of nudge me and try to help me, and I had too much pride in my skill as a physician to do that. So I stopped attending, but you know, I miss it a lot. I really did like it.
Did you ever think that this is a problem that, you know, if we crack it, it'll get us the Nobel Prize?
Yeah.
You know, was that ever a thought going into this field?
I can promise you that the Nobel Prize was far from my mind and Joe's mind. If we wanted to win a Nobel Prize, we wouldn't have worked on cholesterol. It was the least interesting thing in science at the time, and a lot of our friends thought we were crazy to work on this amorphous problem of cholesterol. It's just a lipid, you know, who cares about it? So that was never, ever a goal to win any prizes. What happened was that as we made a series of discoveries, we began to receive prizes. You know, we received quite several prizes. And then people started saying, well, someday you might get a Nobel Prize. And, to be honest, we thought about it. I said, well, it might be nice someday. But we were children. You don't realize how young 44 years old is, but that's how old I was. So I thought, well, if ever there's a Nobel Prize, it's a long time in the future. And so that's why I was shocked at receiving it.
So you've said at multiple instances in the past that the best problem to choose is the one that's the least sexy.
Right.
You should go for the problem that others think is dull. Everyone's going for the hot topics. What's the rationale behind that? What does that really mean?
Well, why do you want to compete with the world? We loved, if I look back on my career, the thing I value the most about it is that Joe and I essentially had this problem to ourselves, okay? No one else was interested. So we were able to work out the whole LDL receptor story, how it binds LDL, how it gets into the cell in coated pits and goes to the lysosome. Every step of the way, that whole thing, we were able to work it out completely because there weren't 50,000 other laboratories working on it. The same thing with our work since the Nobel Prize, the transcription factors that regulate lipid synthesis. We worked out that whole pathway by ourselves. We don't have to read the literature and worry about somebody else scooping us or anything like that. And that's why working on as long as you can get funding for it, if you can find your own problem that nobody else, just think about it. I mean, it's so great to be able to figure something else out yourself and not have to worry that someone else is publishing, It's terrific.
So, your team's work is very basic genetics, biochemistry, and in today's day and age, those topics are no longer the hottest in many ways.
Right.
People want to pursue topics related to gene editing, or everybody wants to tackle cancer, or people want to study optogenetics. So do you think we are not giving fields like chemistry, enzymology, their due course? We are moving way too fast before some basic issues are addressed in these fields?
What is front edge, leading edge science at one moment, the next moment becomes a tool that everybody can use. So the techniques of protein chemistry, biochemistry, people aren't really generating new methods or anything for that, and there aren't great insights. But yet we can use all the tools that the previous generations have given us.
How do you balance your interest when it comes to pursuing a research question that has evolved out of curiosity versus one that is driven by specific goals and applications?
Our goals come out of curiosity. I mean, they're not two separate things. So, like right now, we're trying to figure out exactly how a certain transcription factor is regulated. And we're studying that at the most fundamental level of a membrane protein and how it reacts. But at the same time, we're doing studies in whole animals looking at how this protein works in the liver of a whole mouse. So, we've been able to tackle problems, the same problem, but at multiple levels. And that's been because we're trained as physicians, when we started, we were only working on tissue culture cells, but we weren't content. I mean, almost immediately we started doing animal experiments to test the idea, what we're finding in tissue culture cells, does it have any relevance to the way a whole animal behaves? But the best thing that's happened, over this 44 years is that the tools, the basic scientists have given us these fantastic tools. If you would have said in 1972, someday you will know the sequence of the gene for the LDL receptor, and you will know which base is mutated to inactivate it in any patient. It would be like me telling you that, we're going to have a colony living on Mars in your lifetime. I mean, it would be just as unlikely. Mm-hmm. So we've been so fortunate that the basic biologists figured out how to clone genes and how to purify proteins, and we've been able to apply those basic technologies.
Has there ever been a time in your life, in your scientific career, when you felt that you've maybe devoted too much time and energy into a problem it's not yielding the right results, and it's also leading to problems outside of the scientific realm?
There are certainly times when we've had to stop a problem. We were trying to purify this a transcription factor, a protein that controls fat synthesis in cells. And we had a series of postdoctoral fellows who joined us, and as each one came in, we assigned them this project. They would work on it for a year and fail, and then they would go on. We would switch their project so they could have something positive. And that went on for several years. And you might have said, well, why bother, just stop. But we were just convinced that we could do it. And finally, we found the right postdoctoral fellow who came in and was able to solve the problem. So sometimes you have to give up problems because the technology is not advanced enough to let you solve it. But other times, the technology is there. You just have to keep working at it.
Thank you so much. That was incredibly insightful.
Thank you. It's a pleasure. I'm so glad you're doing this for posterity or students or whoever.
Well, speaking along those lines of communication, you were also the editor-in-chief of the Daily Pennsylvanian
Yes.
when you were an undergraduate at Penn.
Yeah.
And your papers are also often used as a means to teach scientific writing. What's the key to communicating scientific ideas clearly?
First of all, newspaper training, specifically as a newspaper reporter, is fantastic training for telling a scientific story. Because when you write a newspaper article, you have to get all the information into the first 2 paragraphs because people don't read further. So the whole idea is to try to make things succinct so that you can get the main point out first and then fill in the details later. And it's the same thing is true in scientific writing. You want the reader to understand what you've actually discovered from right at the beginning. And then you lay out the story of how you got there. But you never tell the truth. Every scientific paper is a fabrication because you do experiments in a certain order. And it's usually like a random walk, basically, to get to the end. You don't go from the beginning in this logical way. But when you write the paper, you assemble your figures in such a way that it makes it look like, oh, you did this experiment, and then that told you to do the next experiment and the next one. And every scientist knows that that's not true. In our case, what we found was that there were a few senior people in the field of cholesterol that appreciated our work early. And those people were enormously important in giving us the courage to go ahead. And I try now as a senior scientist, when I see a young scientist who has made what I think is an important discovery, but the person is getting opposition from, I go out of my way to try to support that young scientist, because having a senior scientist bless your work is for us, it was tremendously important.
Sir, you're also the co-director of a physician-scientist training program,
Yes.
and you've led it for more than 15 years.
Yeah.
I read a recent article which described how the graduates of these physician-scientist training programs are increasingly not choosing the cognitive specialties, which are internal medicine, neurology, pediatrics, trying something that's non-traditional like dermatology, ophthalmology. What are your thoughts?
My personal bias, what you call the cognitive specialties, are the ones that I think are the most challenging and the ones that lend themselves to real scientific thought. The more mechanical specialties, right now, a fad in our medical school is radiation oncology. Our brightest MD, PhD students are choosing radiation oncology, and they believe that they're going to do some science that's somehow going to improve the ability to use radiation to treat cancer. Unfortunately, when they finally get into that field, they'll realize that they're in a department where the leaders of the department really don't care about research. They basically just want to treat patients.
So you've also stated multiple times that one of the most important decisions a student can make in his or her life is picking the right partner, the right spouse.
Yeah.
So could you share any stories with us about instances when that completely changed the way your science or your life was going at that moment?
Well, I say that choosing the right spouse is not one of the most important decisions. It is the most important decision. And in my case, my wife Alice agreed to move with me to Dallas when I wanted to work on this cholesterol problem, despite the fact that she had no interest at all in moving to that southern city. She did the bulk of the work taking care of our two little babies, and yet she created a wonderful home for me and the children. So I was very fortunate. I've seen numerous examples of MD, PhD students who I think are really smart and have a tremendous potential to make a contribution in science, but they get diverted off into other more lucrative, financially lucrative things, and things that are less demanding on time because their spouse isn't supportive. And so I think it really is important. If you want to have a happy life and you want to devote yourself to this, then you have to find a partner who shares that. And your partner may be somebody who has their own career, and you kind of share child rearing and all of that, but you have to have you have to understand what each person's goals are and work together to make those goals happen.
Now, your work led to the development of statin drugs, which are drugs that now more than 20 million people use for lowering their blood cholesterol. And as a part of that, you've worked with Pfizer, Merck, several industrial pharmaceutical companies. What was that experience like?
Well, the challenge with the statin drugs was that the discovery was made in Japan by a scientist named Akira Endo, who discovered the first statin. And the company was called the Sankyo company in Japan. And Sankyo started a clinical trial of the first statin to lower cholesterol. And they were just in the early stages of the clinical trial, and they called up their investigators and they said, the trial is stopped. Don't give any more to any patient. And the question was, why? And so my partner, Joe, traveled to Japan, happened to travel to Japan for other reasons, but he got to meet Endo. And Endo was very unhappy. The drug that he discovered was no longer being developed by his company. And the reason was because they had done a 2-year safety study in dogs. And because the drug is not toxic at all, they had given enormous doses. I mean, so much of the drug that was crystallizing out in their stomach. Very huge doses of the drug. And the dogs did fine. They actually lowered the LDL to 0, and the dogs were fine. But when they did the autopsy at the end of 2 years, they looked at the intestine and they saw some abnormal cells that they thought were cancer cells. So they said, oh my God, this drug causes cancer, so they stopped their clinical study. Endo told Joe that this wasn't cancer, and we had done studies in our tissue culture cells which showed that if you give enough of this drug, the cell responds in such a way that it changes the way it reacts to certain stains, histologic stains. And we knew that's what was happening in these intestines of these dogs. It wasn't cancer at all. Well, Merck, we were acting as advisors to Merck, which was developing their own statin. And once they saw that the Japanese had stopped their trial, Merck stopped all work on it. And it took a long time before we could convince Merck to resume their trial and their development. And when they did, they finally did a clinical trial, and they were able to introduce the first statin. It's sort of backwards from the way we think of things, because here the Japanese made the original discovery, and the American company commercialized it. But it was because the Merck people had the courage to continue.
Well, thank you so much for sharing that story, Dr. Brown.
Yes.
Now, let's wrap up with our rapid fire round.
All right.
So, I will be asking you a set of questions,
All right.
and your task is to respond with at most one sentence
All right.
with the first thought that comes to your mind.
Okay.
Ready?
Yeah.
What's the luckiest thing that has happened to you?
Finding Joe Goldstein.
What's your favorite part about the city of Philadelphia?
Hoagies.
What's one thing or one aspect of medicine that has not evolved and stayed constant over the last 5 decades?
Treatment of neurodegeneration.
How would you define a successful physician scientist?
One who is happy at the bench and the bedside.
What would your advice be to the following set of people? The postdoc who's struggling about whether or not to apply into academia because of the grant funding pressure, as well as the academic tenure process.
Forget the pressure. If you love science, do it.
To a college student who wonders about what is it that a physician scientist does in his or her daily life.
Work with a physician scientist and watch what they do, and you'll see that it can be very rewarding.
To the high school student who aspires to win the Nobel Prize someday.
It's something that happens to you after you do a great thing in science. But do the thing in science and don't worry about the prize.
Well, thank you so much once again, Dr. Brown. Now, I just want to wrap up with the fact that I read somewhere that you are the only Nobel laureate in the history who, when the time came for giving an acceptance speech, walked up to the stage, tore his acceptance speech, and instead told a joke. And I'm sure our viewers would love to hear that joke. So could you please?
I've told that joke so much since then. You have to understand the setting, okay? Because the Nobel banquet is an incredibly formal affair, and the men are wearing white tie and tails, and the women are in these gowns, and there's a king and a queen, and the queen wears a tiara, and the women are all in these incredible ball gowns, and there are 1,600 people in the room, and they call out your name, and you go up there, and to make a long story short, I walked up to the microphone, tore up my speech, and said, because all the acceptance speeches to me sounded very much the same, and I had written one that was just like the chemist and the physicist, so I decided instead to tell a joke, and I told the following story. It seems that there was a Nobel Prize winner and his wife who were riding in the countryside, and their car ran low on gasoline, so they stopped at a gas station. And it was a very run-down gas station. The owner came out to fill up their car. He was wearing greasy overalls. In the background, they could see the wife who had a chicken coop and was raising chickens just to make ends meet. And the gas station owner filled up their car, and then he came around to his wife's window, and he leaned through the window, and he gave her a passionate kiss, which she returned with some enthusiasm. So the Nobel Prize winner is a man of great breeding. He didn't say anything at the time, but then as they were driving back to the city, he turned to her and he said, what could have possessed you? How could you let a man like that kiss you? What could have gotten into your head? And she said, you don't know this, but that man was my high school sweetheart. In fact, I almost married him before I met you. And the Nobel Prize winner says, well, aren't you glad you married me? After all, I am a Nobel Prize winner. And she said, if I had married him, he would have been the Nobel Prize winner. It got a big laugh in Stockholm. Anyway.
Thank you so much for being here today, Dr. Brown. Thank you all for watching. I hope you've enjoyed this conversation as much as I have. We saw today the story of a 13-year-old boy who fell in love with scientific processes when he was building radios. That passion progressed and changed cardiology and the field of cholesterol metabolism and touches millions of lives. I hope this conversation inspired you, and please stay tuned for our next episode. Until then, this is Divyansh Agarwal signing off on Doc Talk.